Hey guys, welcome back. So today I brought home this 5,000 watt Powermate generator. It is powered by a Subaru EX30 engine and has electric start. This is the first EX30 that I've brought home that has electric start. Now I found this on Facebook Marketplace. It was listed as being 10 to 12 years old. The engine runs well, but the generator doesn't make power. The seller felt that it was just a bad circuit breaker, and that's being a little bit optimistic. You know, circuit breakers do go bad. Potentially it is that simple, but before starting it, I'm going to break out the multimeter. I want to run some quick tests, and if there's no red flags, we'll start it up and see what we get. All right, hopefully you can see the multimeter okay, and I apologize for the wind. It's actually April, and it's snowing and windy, but we'll do this outside. So I'm going to check the ohms first on leg 1 and leg 2. This is set up so that it's leg 1 on the left, leg 2 on the right. You can also use the 240 volt outlet. You just need to locate the one with the tab, that's the ground, opposite's neutral, and each side is leg 1 and leg 2. So I'm going to start by testing here. And usually the reading I see on generators this size is between 0.3 and 0.4 ohms. And in this case we're at 0.4. So that seems like a good reading. Let's check the other leg. The other leg's a little lower, 0.3. So that might be a red flag. Let me just double check the first leg again. 0.4. 0.3. So actually they seem to be equal. So I don't think that's an issue. The other test we can do is check it to ground. I believe this is a floating neutral, so I can just touch it to a piece of metal on the stator and look for a connection, and there is no connection, and the neutral wire is connected to both leg 1 and leg 2, so we know that those coils are isolated and not causing an issue. So I think we're okay to test, but let's pop off the cover down here and take a quick look at the brushes. Okay, and there are brushes right there. We'll just take these screws out. And I'm going to unplug the brushes from the wires, then use the multimeter to test the resistance through the brushes to the slip rings. And we should see a resistance somewhere around 30 ohms. Both the brushes look good. Yeah, it's quite high. It's not open circuit, but it should not be that high. So I'm guessing that this is not going to power up. You know, potentially the slip rings just have a lot of carbon on it, or maybe there is something else going on. You know, I suppose the other test I could do is just check from one of the brushes to the rotor ground and make sure there's no connection. And there's not. So that's good. So if the insulation has failed, it's at least not shorted to ground, but there could be an internal short between the winding itself. Anyway, let me put this back together. I think it is safe to start. and we'll go from there. I've got the light connected but not turned on. I want to give this the best chance possible of powering up on its own. If it doesn't power up, I also have the drill on standby. I'm going to use that to flash the field, which is basically going to induce some voltage and current, some magnetism into that power head to hopefully get things kick-started. Most generators made today, they do have permanent magnets on the rotor, but I know this one doesn't, so potentially it may have lost its magnetism. But based on the readings I get on that rotor, I would say more likely to blame would be dirty slip rings, potentially a blown bridge rectifier, or maybe a fried DPE winding. I don't know which of those it is, so let's get it started and see if we can't get some power out of this generator. Yeah, let's give it a second, but it's not looking good as far as a good running engine, and the battery is losing its charge pretty quick. Okay, I was expecting no power. That's how this was sold, but we do have power. 120 volts, 60.5 hertz without a load. Granted, the engine was hard to start, so there might be a small issue there, but overall, pretty good. So then I loaded it to 3,000 watts, and that's kind of where the problem showed itself. The voltage, it did drop to 108 volts. The engine speed held just fine. Now, this doesn't have an AVR, so the only way to bring the voltage up is to increase the engine speed. So I did bring it up a bit to 61.5 hertz, but it didn't make any difference on the voltage with or without a load. And I think that ultimately is what the issue is here. Because this doesn't have an AVR, the voltage without a load actually should have been higher than 120 volts. Usually I see between 127 and 132 volts on a generator of this type without a load, and we were only starting at about 120 volts. So we are down on voltage, and I'm willing to bet it's the dirty slip ring. So I want to get this back inside. We got to get the end cover off, clean up those slip rings, and try it again. If that doesn't fix it, we'll try swapping out the bridge rectifier. And if that doesn't do it, then maybe this is the way it is from the factory. But I kind of doubt it. So let's get it inside and take a closer look. I realized earlier when testing, I made a couple of rookie mistakes. I guess first off, it's always a good idea to check the throttle plate because the resting position is wide open throttle. And a lot of times when these sit for a long time, a little bit of fuel turns into varnish and causes that throttle plate to stick in the wide open throttle position. And when you start it up, the engine will race out of control. And if you don't shut it down quickly, you will cause damage. And more importantly, I didn't check the oil. I often pick these up with low oil, contaminated oil, or just the wrong type of oil for the season. So it's always a good idea to change the oil. So I'm going to check it real quick. We'll change it anyway, despite how it looks. And as far as the hard starting goes, I do think it is probably plug or spark related, but this is also full of 5 gallons of fuel of unknown age. So there could be issues there. So I think I'll get that out just to kind of eliminate that from the mix. We'll get the plug out, take a closer look at that, and then move on to getting that end cap off and checking out and cleaning up those slip rings. Yeah, thankfully there's plenty of oil. A little bit low, a little bit used, but overall pretty good. Let's check the fuel in the bowl next. Fuel actually looks pretty good. There's no water. The color looks decent. And there's a bit of debris on the bottom, but pretty good. I'm still going to drain the fuel anyway, but I don't think that is the hard starting issue. So let's get the plug out and have a look at that. Well, at least it's a name brand, NGK. Most likely the original plug on this engine. You can see it doesn't look great. The gap might also be too big. So let me double check, see if I have a new one of these. Otherwise, we'll clean this one up and re-gap it. Although I did find a brand new plug I can put in here. It's of lesser quality. So I'm going to try this one first. This is the one I just pulled out. I wire wheeled it, knocked all the carbon off. So let's hook it up and turn the engine over and see what the spark looks like. Yeah, plenty of spark. So let's drop the plug in the hole, try starting it, see if it's any easier. Let's try it again. I'd say the hard starting issue is solved just by cleaning that plug. Now, the engine was smoking quite a bit, and that's not too unusual for these Subaru EX30 and EX27 engines. They smoke quite a bit at startup, but it does clear within seconds. Anyway, you get the idea. I'm going to keep going until the tank is dry. As far as these bottles go, I always use clear bottles when draining tanks of unknown origin. I just want to see visually if there's any water in it that needs to be removed before using this in something else. So this I'm going to filter with a coffee filter. It's going to go right in my car, and I'm going to store this dry. Any additional testing I do, I'll just use the test tank. I've already removed the brushes again. To get this end cap off, you have to actually remove the stator bolts. There's 4 of them in total. Not the best design, but that's how it's done on these. That stator looks practically brand new, but you can see the slip rings here, especially the inner one. For whatever reason, that one carboned up quite a bit more than the outer one. So yeah, it might be a good idea to swap out those brushes. I have a couple used sets, so I'll put one of those on instead. Now I have direct access. I'm going to check the ohms once again before cleaning it, and then check it again after. I think this should be somewhere in the 30 ohm range. Yeah, we're getting 34 ohms even through all that. So yeah, I would say the brushes are more to blame than what's going on here. A piece of Scotch-Brite works well for cleaning these up. That there is the back side of the bridge rectifier. You really can't see the front side unless I uninstall it. But I do have one right here, and that's what it looks like on the other side. It's just a few diodes and a capacitor, so not a whole lot to it really. And I don't suspect that's the issue based on the ohms reading, but I guess that is a plan B if it comes to that. You know, as far as some used brushes we can put in there, I've got a set right here, and I think one other set right here. So I'm just going to pick out the better of the two, get those installed. After I get the end cap back on, we'll double check the ohms, and hopefully we're close to that 32, 33 ohms that we saw when testing directly to the slip rings. All right, let's check the ohms through these brushes. Hopefully it's close to 33 ohms. We're at 36, so that should be good. I am pretty much ready to go. I've got the fuel connected and turned on, and a couple multimeters on standby. This one here is connected to the battery. I believe this has a charging system, so we'll see once it's started if that voltage comes up at all. But we are starting at 13.17 volts, and the multimeter on the end is also set to check DC. I'm going to touch the probes to the brushes and see what the voltage is at. You know, something like this, I'm expecting around 80 volts DC. And as far as the load goes, I've got the two heaters on the left connected to leg 1, the two on the right, leg 2. Once running, I'll verify that the voltage hopefully came up closer to 128 volts. I'll put the small heaters on full, which are 1500 watts each, and the middle on medium, which are 1000 watts each. So this will bring it right up to the max of 5000 watts, if not a touch above, and we'll see how this thing does. I'm a little bit shocked. I thought for sure the voltage would come up based on the resistance readings that I got earlier, but it did come up, but not by much. Without a load, it was at 124 volts, and loaded to 3000 watts, I saw a very similar voltage drop to about 109 volts. And then when I loaded it to the max, it brought the voltage all the way down to about 100 volts. So we definitely have an issue still with that power head. So I do need to get it inside, take a closer look. You know, as far as the charging system goes, yeah, I don't think this one has one. It was not charging the battery. And when tracing the wires here, I don't see that there's anything connected to the system to maintain that battery. So it does need to be maintained manually. And the voltage at the brushes, it was 76 volts DC. And that's what I was expecting to see based on the resistance of that rotor and the expected output. So now I'm kind of scratching my head a little bit here. I'm kind of wondering if there is actually an issue with this power head, or, you know, is it the bridge rectifier, or is it something else? So I'm going to have to dig in a little bit deeper. So let's get this back inside. We'll get the cover off again and take a closer look. Interesting. There is a bunch of extra wires that I usually don't see. Usually there's 5 wires. In this case, we have a total of 8. So what I want to do is test the windings individually to make sure the insulation between the windings is good, because I did already check it to ground as well as the rotor to ground. There's no issues there. Potentially something is cross-connected between leg 1 and leg 2, or there might be an issue here with the yellow wires. This is the DPE winding. That's what supplies power to this bridge rectifier. So I think I'll start with that. I'll just disconnect it, check the resistance of the winding, and check it to ground, and check it against the other windings to see that nothing is cross-connected. On this winding, I'm not exactly sure what it should be. If this was a newer generator with an AVR, I would say it should be around 1.5 ohms, but even something like this, I would expect it kind of in that 1.5 to 2.5 ohm range. And we're at 1.2. So that seems good. Check it to ground. And no connection to ground. So that seems to be good. This connector is a bit different than I normally see on these Powermates. It's populated with 8 pins. Usually I only see 5 pins. The middle is ground, which it is in this case. And then usually diagonal is leg 1, diagonal is leg 2. But that still leaves us with these 3 extra pins on the middle. We have a red wire, a yellow wire, and a black wire, which looks like they head over to the engine. So let's take a closer look on the engine side to see what those are. And these are the 3 wires from the 3 extra pins. We have the black wire, which ties into the low oil system and then goes down to the ignition coil. So this is the wire that kills spark when you turn the switch off on the control panel. The yellow wire goes into the starter. That is actually connected to the start solenoid, and that is just connected to that switch right there. And then the red wire actually might be the charging circuit, the one I thought we had, but after just testing it, I didn't see it doing anything. But I think I misread that, because that has to be a charging circuit. You know, we have the hot wire here coming from the battery to the stud, and then this wire running up, which presumably when the generator is running, it should be sending power down right back into the battery. So these 3 wires I think we can safely ignore for testing the health of the stator. So diagonal is leg 1, and diagonal the other way is leg 2. So I want to check between leg 1 and leg 2. There should be no connection whatsoever if the insulation's good. And there is no connection. So all the low voltage tests are coming back well. You know, the ohms here are good, no connection to ground. Leg 1, leg 2, not connected to ground, not connected to each other. You know, I guess the one test we haven't done is testing leg 1 and leg 2 to this winding down here. So let's actually use this, make it a little easier. And we'll check leg 1 to DPE. No connection. Leg 2 to DPE, no connection. So yeah, everything is looking very good. I still can't find any issues with the stator or the rotor. So let's get the bridge rectifier up on the bench, take a closer look at that. The diodes look okay. I don't see any obvious sign of a problem, but it is a little odd that there's 8 diodes. You only need 4 for a full bridge rectifier. So the fact that there's 8, most likely they just doubled up to get more capacity. And the capacitor, it does look maybe a little suspicious. It looks slightly bulged. So let's test the diodes and circuits, see if we can't figure anything out. And we'll try the capacitor as well. All right, let's check this first row of diodes. Voltage drop 0.51, 514, 514, and 511. So let's just reverse that. And if the diodes are working, we should not get a voltage drop. And yeah, this row looks to be good. Let's check the next one. 514, 519, 519, 513. Checking it the opposite way, we should get no change. So the diodes seem good. Let's check the capacitor. It's rated at 470 microfarad. So let's see if it still tests at that. All right, let's double check that the capacitor is discharged. And it is. That could be a problem. It's not reading any capacitance. Granted, it's in circuit, so that could be the issue. But let me get the other board, check the capacitance of the capacitor on the other board, see if it gets the same inconclusive result. All right, good. There's no power in there. Let's see if we can't get a reading off of this one. Nope. Can't do it, which I'm not that surprised about. Capacitors you do normally need to take out of circuit. So I'd say at best, this is inconclusive. But based on the visual evidence, I would say that the capacitor on the left is most likely bad. You can actually see a dark spot right in the middle where it most likely vented. And it looks like this metal is separated a bit. Whereas if you look on the right, that capacitor looks perfect. So let's give this board a try. I do have a third option. Well, not really, but this is an aftermarket bridge rectifier for a Powermate. And you can tell it is different from the OEM one in that the capacitor is a lot taller, and it's actually only rated at 390 microfarad, which might be an issue. Unfortunately, I never got to test this board because this tall capacitor actually prevents this board from being installed. I can't drop it all the way in place. So yeah, pretty big oversight by whoever made this board. They didn't even see if it would fit. I'm going to pause it here. You've already seen how to reinstall that end cap. So turn you back on in a second outside. Yeah, I finally figured this out. So this wire that's running 12 volts up into the control panel, the purpose isn't to send a charge down to the battery. It's actually to send power down to the start solenoid when you hit the switch, like this. So yeah, there is no charge circuit on this one. Place your bets. Is this regulator gonna fix it? Let's find out. Nice, 132 volts. That is a big difference. The voltage without a load was 132 volts. And on a generator like this without an AVR, that's the upper end of what you should see. So I loaded it to 3,000 watts. Voltage came down to 120 volts, and then brought it to the max of 5,000 watts, and the voltage held at 110 volts. So yeah, the original bridge rectifier definitely has a bad capacitor. So I'm going to hold on to this, get this fixed. This is actually a discontinued part, and I'm sure I'll need it in the future. As far as the voltage goes on the brushes, also saw a big improvement. It went from 76 volts DC up to 127 volts. So yeah, at this point, I would say this is a good generator. It just needed a little repair, and it lives again. So I hope this video helps someone. Thanks for watching.